This video will cover the basics of debugging an MPI C++ program with Valgrind, TMPI, and GDB. This program, which has not yet been parallelized, simulates the heat equation on a rectangular grid with edges fixed at 0. I'll convert it to an MPI program using MPL, adding a few bugs and explaining as I go. The mechanics of debugging will be emphasized and the particulars of the problem breezed over. I'll first create a function that equitably divides work between processes, allocating to each process the rows that it should be in charge of given the boundary conditions I've chosen. Now I'll add a few MPI variables, namely a communicator, its size, and this process's rank within the communicator. The constructor needs to be updated since each process will only hold a portion of the grid. Plate and new plate will contain the rows this process is in charge of, plus 2 halo rows to facilitate inter-process communication. The exchange halos function will accomplish this communication, syncing grids at the end of each iteration. It does so by creating a layout that represents a single row and tags for sending and receiving between processes, then using send-receive to swap halo rows. If statements ensure that the first and last processes don't try to send data to and receive data from non-existent processes. The step function, which iterates the hot plate once and keeps track of the greatest change in any cell for that iteration, needs to be modified to operate only on the rows that this process is in charge of. Additionally, since the greatest change in any cell could occur in any process, the local max change must be determined, then reduced among all processes to determine the actual max change for this iteration. Finally, halo rows are exchanged. With that done, the program works with one process but dies due to a segmentation fault with 2 processes. Valgrind shows that the problem is on line 62, where the plate is being initialized. Correcting the for loop to iterate over only the rows that this process stores fixes the segmentation fault, but leads to another issue reported by MPI run itself. An error in MPI send-receive means that something is wrong with exchange halos. On inspection, the send-receive that is meant to be communicating with the process to the left is actually communicating with the process to the right. Correcting this makes it work, at least for 2 and 4 processes, but the incorrect result with 9 processes indicates a subtle bug. TMPI can be used to run GDB on multiple MPI processes at once, multiplexing input commands automatically for ease of use. Setting a breakpoint at the end of the step function, then running and backtracing reveals a problem. The first row of each process's plate is incorrect. The leftmost active cell should be 37.5, the average of 3 50s and a 0, and subsequent cells should be 50, the average of 4 50s. Looking at new plate reveals the problem. Halos aren't exchanged before the first iteration takes place, so the halo rows are uninitialized on the first iteration. Fixing this results in a working program.